this is what I believe is how event logger works, or event logging works in a typical Linux server, Linux system. Here at the top, we have a commonly deployed system in recent Linux distribution, such as Rocky 8, based on Red Hat. Different application natively send events to sytemd-journal, and also sytemd-journal through a daemon called sytemd-journal-d-devlog implement this dev location as seen in here to capture other events that are sent by application that send or log events directly through this Unix socket, and then later captured by sytemd-journal. And a dual deploy application, then we would have, or we would see sytemd-journal, sytemd-journal, or rsyslog as being the default on Red Hat and Red Hat based Linux distros, or syslog-ng. Both implement syslog protocol or syslog events. So the one at the top is the typical implementation, and so once everything is being gathered by journal, then the rsyslog, if it is present on the system, then it's going to come to the sytemd-journal database and capture that information to pipe it into the syslog logic. This is the rsyslog conf located in etc. This is the default configuration in a Red Hat based distribution as seen in here. It's got the Unix socket input module, and also it's got the journal input module loaded. So this is what that is known as a deployment with sytemd-journal plus rsyslog, both working or coexisting in the server. So the rsyslog website recognizes that this is the typical deployment, a very known deployment, where it can coexist with the systemd. So they communicate as expected through the devlog. Systemd creates the devlog system, and then systemlog or rsyslog gathers that data through the journal database. So we can see this coexistence and information, this description directly from the rsyslog website. Here in the Red Hat also we can see the typical explanation of rsyslog working in conjunction with sytemd-journal and how that works. But I'm putting this just for documentation purposes, and if everyone watching this video can go read and learn from the source. In my deployment, I had planned to have them both to coexist, but because I was unable to properly load the journal module and capture events that were supposed to be sent to a specific section of rules on rsyslog, those instructions or parameters on rsyslog are not working. So this is the default. Let me go to my testing rsyslog. This is how it looks like. So originally I had the Unix socket module, input module loaded, plus the journal module loaded as well, plus the parameters for each one. This one for journal and this one for Unix sock. When you enable this instruction and you run it, so for example, if I enable that and I run this through a check of the configuration, we can see there is a very annoying error. Well, I haven't loaded the module. So once the module is loaded, then it goes to the next instruction related to the journal, and it says that this input statement is does not support this input statement. But this version of the rsyslog, you go and look it up in the input modules. You can see examples where the documentation is quoting the input statement with the module, and it's supported just fine. So this is a newer deployment, but apparently the input statement is supported since version 7. So I don't see any reason. I was looking around to see what is missing to be able to load the input statement, but I wasn't able to. The reason why I need the input statement on journal is so I can send so I can send a specific set of events to a isolated rule set. It's I will get into the rule sets later on, but I needed it that everything that is generated for the local host internally to this server was contained in his own rule set. So I needed this, and I wasn't able to make it work. So that's the reason why I went with the Unix sock only method to capture events. So to make it to, quotes, eliminate journal from the picture and leave only rsyslog, this is what is being suggested by Red Hat as the solution. This is an article that was created in October 2024, 1 year ago, and this is what is need to be done. So the other reason that is mentioned, people want to use journald as an event logger, is that journald is better integrated nowadays in the different distribution, and also provides metadata, much more rich structured logs apparently, and that more data could be used. The rsyslog, on the other hand, is used more exclusively for mitigate, via sockets. Essentially, this operation of rsyslog, or going into systemd to read events, costs a lot, and also not only costs because of the access to the database, is also because it has been found or documented that that operation has come with a lot of bugs, causing infinite loops into the rsyslog, causing all sort of issues. It's supposed to be fixed by these newer releases, but that's the reason why typically it's not advised in deployments where event performance, such as, so this is the default that we have on most of the Red Hat or Debian based Linux distribution. But this below is the one that I want to go to. So essentially, I'm looking to cancel because of me unable to set up this sytemd-journal input module correctly to trap those events from the local system. I wanted it to just eliminate altogether. This advice, eliminate this, eliminate, and then eliminate this, and essentially let application to talk to rsyslog through the devlog directly, and have every other application natively speaking to systemd, sending events, and have systemd forward events directly to rsyslog. So basically systemd becomes a client for syslog collector and also all the application. This is the setup that I want to get to. So this is what we want to do, and eliminate all this, and this is the architectural overview. To do so, advice from Red Hat is disable the journal module and forward the events to syslog. Also to configure on rsyslog daemon the syslog sockets. That's basically what it is. In the default deployment, devlog is managed by sytemd-journal. Let me just show you what it is, how it looks like. Oh yes, this is still here. So journal, systemd-journal in charge of this daemon, helper daemon to systemd-journal, creates this location, which is then limps him to devlog, and so everything else talks to pumps data directly to systemd-journal, captures data. This, we want to eliminate this as seen, so that's the one at the top. And after we eliminate that, we want to get to this, which is essentially, now it is its own direct Unix socket or device as in here. So how do we got to this configuration again? So coming back in here, we disable sytemd-journal in rsyslog conf, disabled, and the parameters of the input or listener from journal is disabled, and so we only have the Unix socket module to capture local events. This UDP, we're gonna get into that one later on with the additional setup that I have, but this is for the network, for other devices that are pumping in. So for the local system, instead of having a journal and Unix socket, we're gonna just have this one. Okay, that's the relevance configuration for rsyslog at this point. And then for the journal D, we're gonna get 2.5. So the default of the journal D, the default setup comes with this commented out. So we uncommented, and then we uncomment this as suggested by the Red Hat article like this. The rest of it is commented, so it's effectively disabled. So this is going into this journal section as explaining here. That's the first part. The third part is to instruct the rsyslog daemon to create and manage the syslog socket. That's what we're gonna do. This destination is not accurate on this Red Hat 8 anymore. Probably was in the previous one, I'm not sure. The right location is this location, right? So this is where we want to go. And so from that, Red Hat is telling us what you need to do is require syslog socket and this alias as well in this section, corresponding section. So this is what we have. We have a little bit more than is in there, but this one came commented. So now we uncommented and activated, and also the alias originally came like this, and so we're doing this. We save, and now rsyslog is going to be in charge of creating this device, this system device file, and manage it, create it, uncreate it, delete it. And so that's what we do. Oh, and the previous configuration, the forwarding piece, this is what I shown. Let me just go back to it. This. Oh, sorry. This is this. So technically everything that is talking to systemd-journal directly, natively, is going to now send that, forward that information to syslog. Oh, actually, now that I think about it, it's not like it is painted here. I think I'm going to paint it. It's going to be like this. That's how it's going to inform syslog of. So now this is not going like that. So now this is how it looks like. Systemd-journal is now going to talk to the Unix socket and send events from other application directly to devlog Unix socket, and directly pumping into rsyslog. Same for application that directly talk to devlog device, Unix socket device. It seems a little bit more cleaner, but for some reason this is the one at the top is the typical deployment for Linux distribution nowadays. So now that we have those configurations in place, the final section of this article calls for us to run this, inform all the different daemons of the change, enable rsyslog, and restart the rsyslog and systemd-journal service to match, to change from this flow of events to the one at the bottom. That's what we do. So with that we finish this. This is for the documentation. Now let's go into what I want to do. Now in the rsyslog, this is my new configuration. The rsyslog has two different notation: the classic, legacy, and the Rainer script syntax, which is the one that I'm using. That notation is with very similar to a language programming, with function, parentheses, everything in in sections. So in this notation is very useful for a much more complex setups and readability of the syntax. So that's the one that I'm using. My goal was to bring it to this one. So let's eliminate what I had before, and let's focus on what I have now. So now I'm gonna have a separate device that is going to be sending Hitachi HCP as an S3 storage target. This guy has been configured to send data, to pump data through the network. A UDP standard port, well, not a standard, but 5144. So that's the configuration. I load the module, the input module UDP, which gives me network capabilities, and then I open the listener on this port, and then I configure the syslog forwarded on Hitachi to send me events directly to rsyslog. So that's what I'm doing. My goal is to clean events from this guy and send it later on to a different box that is running various ports, but the one that I'm going to be pumping through is UDP. Once I clean it up in this central location, I send it to this guy that is running Grafana Alloy. So I am able to later on visualize the events by Hitachi on this box. So that's what we're gonna. That's my goal, because once why am I passing it through a separate rsyslog collector is because originally I had this one sending me data, and it was so much data that it brought down the box. So I needed a better box to analyze the data, why it wasn't receiving the default format that this one was sending the syslog data. So I needed to inspect the data before and capture and clean it, and once that was done, then I can either redirect it or just keep it clean like this. But I need to transform to see what's going on with the data that is being sent into this location. Syslog events are governed by RFC 5424. There is a previous one that are being bundled into this one, but this is the newest that governs syslog protocol 5424, RFC 5424. From this, we're interested in the syslog message format. Let's go to that section. Every well-formed syslog event comes with this structure: a header followed by a space and followed by structured data and optional messages. This one I have realized after testing that this is the minimum required to implement, so other syslog messages can receive and correctly an event. The header, this header, is formed by this priority field, followed by a version field, followed by space, followed by a timestamp, followed by space, followed by host name, followed by space, followed by application name, later on will be called service name, followed by space, followed by process ID, followed by space, followed by message ID. Right, this is the header, and then after that comes this one. So this is the one that I'm going to be showing you right now. So once I receive the messages coming from here to rsyslog through the UDP 5144, I send it. This is like a jump. I send it to a section that is called rules. So everything, once you in rsyslog is called, you call the module, then you put the parameters or open a listener, and then depending on the listener, it allows you to specifically send every event to his own jail or section, so you can work with it, separate it. So I go to the SCP rule set. This rule set is called like that, and then in every single event is going to travel through these different instructions, and where we can massage and inspect. We cannot change the original fields on the event line, but we can create our own message or format out of them. So we can intercept and take some data and create or clean it and create and send our own line to other devices. So this is what I'm doing here. Basically this is testing, but I'm not doing nothing yet in here. I just needed this rule set to provide an action to inspect what was coming originally from there. So this is where I was playing, sending it to disk in the various formats. Template is basically the mechanism that allows me to inspect the different events in various format depending on the template chosen, right? So I can define my own. There's rsyslog provides multiple ones that are already ready for you to use if you know how they are going to format the data. And this one is the one that I based off this one. I created on my own to implement that format. So let's inspect that template. So now from the rule set we jump to the template, and this is the template. There's various also types of templates. There's string, list, and JSON, I believe, or tree. This is not important right now, the type. The only thing that I know is that this is going to help me to intercept the event by calling the different fields. On rsyslog, the fields are called properties, but they are the ones telling us that the actual properties are actually variables. So the properties are actually variables that allows us to tap into the various fields that are coming predefined in a event log, right? This is the most important ones listed on the rsyslog website: the message, the priority or the pre-header, the host name, the message, everything that we can inspect for that the rsyslog, when receives a event from any of the doors, the ports that it has open, is parsed to. So this is what I'm doing. I'm recreating that template, a new template based on what it is being, based on the RFC that I showed earlier. Reopen. Yeah, this one. So it has a pre followed by a version, has a pre or brackets. This is all explained in the RFC in here. And this followed by this one, then the private. Yeah, this is very well explained in here if you want to take a look, but this is how I implemented, or to the best of my knowledge, that those header. So the pre, I take it through a property. This is a variable that is parsed to pre by the rsyslog, put it in here. Then next is the timestamp. This one, the time reported, is essentially the same as timestamp, but then there's a few. If we want to see what's the difference between them, you can come to the rsyslog documentation and check. This one seemed to me the most important one. These parameters of this property it was originally they come like this, date format, but this will fail the syntax. So they mentioned that you don't have to, even if it is time reported, I think time reported, the attributes or parameters are explaining put the date for various format, then it's going to fail. You have to remove date dash and leave it like that. This is how it's going to work. So before I knew that, I have to play all of it with my own RFC 3339 and build it all by myself like this. It's unfortunate. So I was playing with so many ways until I understand a little bit more, and this line is essentially replacing all this block. Okay, so continue with the formatting of the event. Then I continue with host name and removing I'm just leaving the first part and just removing the rest of the TLDP name, the full name. In here I continue with the app name property or variable. Supposed to name it as service name, but it doesn't. Anyways, I don't understand this very well, but I'm picking this up and creating my own, or extracting what I believe should be the service name. This one comes as a name that I don't want, that I don't like, so I'm hard coding it down. I'm hard coding it down here, down below here. I capture proc ID, message ID. This I captured them. Originally, this one I'm duplicating it because up to here is what I believe is complying with the header, but this one, if I don't put it, then I pipe it to the next upstream rsyslog, it still rejects my message, so I put it here, and that's how I got it to accept my message. And this is additional enrichment of data that I'm collecting from that event and that I'm forming my message to send. Once this is collected, then is being sent upstream via this 54. So what I'm doing is every event comes through the input, then comes to the rule set, and this via an action is forward to the next upstream syslog on this port with this format, the format that I just with this format, which is translate to a template. That's how basically works what I'm trying to do here.